Hello everyone, and welcome to our annual panel discussion on career paths in STEM. My name is Aaron Geller, and I am the director of our Research Experiences for Undergraduates program here in the CIERA Astrophysics Center at Northwestern. We have a great panel lined up for you today. I want to make sure to thank our panelists and also thank all the students joining us from across the country. It's really great having you all here. We have currently 100 participants, plus all the people that are in the room here. So this may be one of the biggest groups that we've had on Zoom, and that is awesome. So thank you all for joining us. Before we begin, I just want to take a quick moment to provide some motivation for this discussion that we have here. Students who go into physics and astronomy and related fields gain many transferable skills that are highly sought after in a wide variety of career paths. But because students are embedded within an academic department, they sometimes see the academic career path as the only option, or an option with very strong weight. But in reality, many students in physics and astronomy do not continue in the academic career path. And instead, they pursue a wide variety of careers that are all very interesting, very important, very fulfilling. And so this panel has people who have gone through education in physics and astronomy and are now in a wide variety of careers. So this panel discussion and the others that are in this series on YouTube, we aim to help provide some information about the broader landscape of careers that are available to students studying STEM subjects, and to give you all an opportunity to ask questions of these experts in the career today. So with that, I want to hand things over to Emily Liner, who's the co-director of our REU program. Emily did an awesome job. She organized this panel, and she's going to help to guide the discussion today. And so, Emily, please take it away.
Yeah, thanks, Aaron. So, if you don't know me, like Aaron said, I'm Emily Liner. I'm co-directing the REU here at Northwestern, and I'm also a professor at Illinois Institute of Technology. And thank you to all of the panelists who agreed to do this today. We're really grateful that you're here to provide all of your wisdom to us. So let's go ahead and get started. And I thought we'd get started just letting everyone on the panel give a quick introduction. Just, tell us your name, where you are now job-wise, and then just a brief bio of, how your career trajectory has been, how you've gone from, grad school to be where you are today. So I think we can just go in order of how you appear on our screen. So we'll start with Erica, and then Jenna after that, then Jason, then Aaron, then Raksha. So I will turn it over to you, Erica, to introduce yourself.
Hello, can you hear me?
Yep.
Hi, my name is Erica Carlson. I'm currently a science writer at the American Physical Society, so nonprofit org, professional society, like the AAS for astro folks. As for my quick bio, where I've been, what I've done, got my bachelor's in physics. I did some research before deciding I wanted to go to grad school, went to a PhD program in astronomy, did not end up finishing the PhD, but I left after my master's degree because I decided I wanted to go into science writing. So I did a couple of different programs to transition from research into science writing. I did what was called the AAAS Mass Media Fellowship, which is a program designed to help scientists transition into writing careers. And then I also attended a grad program for science communication specifically at UC Santa Cruz. So I did that, did a couple internships from there, did freelance science journalism for a while, as well as freelance institutional communications for science research institutions. And about a year ago, roughly, started my current job at APS, American Physical Society, as a science writer.
Awesome, thank you, Erica. We can go on to Jenna.
Hi, I'm Jenna Ryan. I'm a senior staff scientist at the Space Telescope Science Institute in Baltimore, Maryland. And I suppose a little bit of a background. I also did a bachelor's in physics, and then decided I did want to continue on in grad school, try to get a PhD. So I did that, and then directly out of PhD, I joined the Space Telescope Science Institute. I suppose at the end of my PhD, I was kind of trying to decide if I wanted to continue on in self-directed research. And I applied to a few postdocs and also applied to the job I have now, which is, as maybe I'll explain in a little bit, is not based in self-directed research. But I ended up not getting any postdoc offers and ended up getting an offer here. Also kind of at the same time decided the research path wasn't really for me anyway. So I took the offer to come here. Yeah.
Okay, thank you, Jenna. Jason.
Hi everyone, I'm Jason Wong. I'm an assistant professor here at Northwestern University. But my background, I was also a physics major undergrad. I also minored in computer science. I did some, actually, in addition to doing some research like astronomy research, I also did an internship in software development. And I actually eventually turned down some job offers in software development to pursue grad school in astronomy. And then after that, I did 4 years as a postdoc after getting my PhD in astronomy. And then I started here just last year as an assistant professor.
Okay, thank you, Jason. And Erin?
Hi, everyone. My name is Erin Boyle, and I'm currently a staff machine learning engineer at Tesla. When you hear that name, you probably think of cars, or maybe you think of other things. I don't work on cars. There's a less than 10% fraction of the company that most people don't know about, which is the energy org. So we do a lot of clean energy related projects. And so I actually work on the software that determines how the utility scale batteries that Tesla manages dispatch into energy markets all around the world. And my path to get here, I would say, is somewhat circuitous. So in undergrad, I did chemistry and math. In grad school, I did physical chemistry. So I guess I'm kind of sneaking in under the physics banner. And even within that time, I would say I worked actually in 4 different labs and kind of explored a number of fields that were all motivated by an interest in doing something environmental, potentially related to climate change. Decided to do something more applied after I finished my PhD and got interested in becoming a data scientist. I did this Insight Data Science Fellowship, which is for specifically people with technical PhDs to kind of transition into data science. That was back in 2015. And after that, I spent actually 5 years just working as a data scientist and machine learning engineer, actually at Stitch Fix, just in the broader kind of corporate tech world, did recommendation system stuff, got good at machine learning and production software engineering. From there, went back to work in clean energy. I spent 2 years as head of data science of a little startup called Mist AI that built a forecasting platform for clean energy companies. That startup got acquired by Snowflake, and just about 3 months ago, I started at Tesla.
Awesome, thank you, Erin. And to finish us up, Raksha.
Hello, everybody. I work with Emily. I have a joint appointment. So I'm like a professor at Illinois Institute of Technology. I'm in physics department with Emily. And then I'm also a staff scientist here at Fermilab. And my expertise is in quantum sensing. So I use quantum devices and techniques to look for dark matter. So I started my journey as an undergrad. I grew up in Nepal, and I came for undergrad in this small liberal arts college in Oregon. I did my undergrad with a double major in physics and mathematics in 2004. And then, 2004 I started, 2008 I finished. And I wanted to go to grad school in physics. However, I was really bad in standardized tests. So I did poorly in GRE, and I was like, okay, I'm going to just like take a year off and then do some more research. So I came to Fermilab, did research for 9 months or so with a scientist here. And then I applied for a grad program and got into physics grad program. So by then I had done like research internships for undergraduates, kind of like this program here, several of those, including one at Fermilab. And so that made me competitive for grad programs. And so I went to
Purdue University, and I have a physics PhD from Purdue. That was in 2015, and I did my postdoctoral research at University of Washington in Seattle in particle physics. And then I also did my second postdoc here at Fermilab. And I kind of transitioned from astrophysics to like quantum sensing. So I do kind of like immerse both of those areas right now. So yeah, and right now I lead one of the projects under Quantum Science Center here at Fermilab. And I have my own graduate students and postdoc and scientists. I have a big team here. So yeah, that's kind of like my academic journey, I guess.
Awesome, thank you so much, Raksha. So welcome to all of our panelists. Thank you again for being here, and we're just gonna open it up for a Q&A. So if you guys have questions, please put your hands up if you're in the room, or put your hands up on Zoom if you're on the Zoom chat, and I'll kind of go back and forth and call on people to ask questions. Feel free to ask a question for a specific panelist, or you can ask a general question that you want, you know, everybody's input on. Pretty much anything goes. So do we have any questions in the room?
I have a question.
Okay, yeah, why don't we start with you?
So specifically for like those of you in the panel who kind of went into less academia strict fields, what was your transition from getting your PhD, like going into industry? Like what was that transition like in your life, and what were some of the difficulties and good things that came out of that? Okay.
Yeah, do you want to ask a specific person or just anyone?
No, just for all the panelists.
Okay.
I'm happy to jump in. I can start, someone else can follow up. So I started mentioning like my specific transition was after my physical chemistry PhD. I did this Insight Data Science Fellowship. There was a little bit more to it than that. I actually took like 6 months off in between, and initially I was considering doing the AAAS Science Policy Fellowship, which still seems like a really cool program to me. And there's all these interview steps, and the last step is that you present to a panel on a project. And I presented on the electric grid, which wasn't something I knew about before then. And I just found it super interesting. And I happened to, at the same time, just be taking data science classes online, just kind of out of curiosity. And because I had moved to San Francisco, that's what everyone in San Francisco does. And I kind of put together like, oh, there's a lot of data science in this very like climate impactful field. This would be really interesting and really impactful to work on. And so I said no to the AAAS. I looked for some kind of way to get into data science, and I actually applied to a couple of these programs, and I chose the Insight one because at that point in time anyway, it was a really good way. They placed like basically everyone that went through the program into some kind of company. It was kind of an obvious stepping stone. And before I did that, I actually did a couple months of contract work, just got a little like contract freelance data science job, and that helped me learn like, I'd kind of picked up some ML type stuff in my classes and, more statistics and stuff. But then in that contract work, I, had to use AWS and got some familiarity with some of the cloud services. And so that meant that after I did Insight, I was, a decent candidate, ended up being able to go to a pretty cool company. I think things are a little different now than they were back then. Like back then there weren't data science degrees, and now there are. And so I think the path is a little bit different now. Like there are definitely still people that hop from physics to data science, but it's not quite the deluge of people that it was 8 years ago. And so, yeah, I would probably, advise that people look for slightly different paths than what I did at that point in time.
I can answer this question a little bit too, maybe. So like Erin, I was also applying to kind of fellowships and programs that would help me transition from grad school into the career that I wanted to do, which was in my case, science writing, science communication. And of course, those were extremely helpful in preparing me for like what a career in science writing was going to be. And as for kind of how that transition actually was for me, or what things were kind of different from grad school, I think that was probably part of your question. There were a lot of things that were pretty different from academia in terms of just day-to-day things I was doing and timescales I was working on. In academia, when you're doing research, things are, you're working on things for months or even years, and things move along on like pretty slow timescales. But at least in science writing, I'm working on things with all sorts of deadlines. Some things I turn around in like a day or a few days. Some things are weeks or months. It depends on the project that I'm working on. But if you're someone who likes to work on something, like a lot of different things, or work on a lot of different things, kind of moving from one thing to another, or just be able to work on things on a little bit quicker time scale and not spend forever working on the same thing, that can be something that's potentially interesting, I think, about a lot of industry or non-academic jobs. Of course, this really varies from industry to industry too, and like building skills you're working on. But for me, I appreciated and I liked being able to work on a lot of different things and move from one thing to another and not be working on the same thing like constantly.
I could jump in here too. I've sort of mentioned that my role here is not really, it's sort of academia adjacent, I guess I would call it. So I guess I didn't really explain in very good detail about what my job is at the Institute, the Space Telescope Science Institute. But I'm on the Advanced Camera for Surveys instrument team, which is one of the cameras on the Hubble Space Telescope. And so my role is more like science support rather than direct, science research. And I would say the transition from PhD to this role was not, I didn't need to do any sort of programs like Erica and Aaron mentioned, sort of transition. So it's a little bit more of a direct path from a PhD in astronomy or even a bachelor's or master's in astronomy to the role I'm in now. I use a lot of the same skills that I gained in grad school in my current job. But I also learned a lot here. Because we're doing more science support, we do a lot more maybe software development and interacting with our community of users of the Space Telescope. So I learned a lot of best practices in software engineering just through the job. And then also, a lot more interaction and sort of problem solving with other folks collaboratively. My PhD was rather sort of very self-directed, very individualized. Yeah, and I guess I'm not sure I faced too many challenges in the transition time because came kind of directly from PhD. But yeah.
Cool, thank you guys. Any other panelists want to say anything? Otherwise, we'll go on to the next question. Okay, I think Nahalia, it was the first up from the Zoom call.
Yes, thank you. My name's Nahalia Samuel. I have a direct question to Jenna, and I have a question that I would like a perspective from Jenna, Jason, and Rashad, please. So, to Jenna, you said something about you decided not to go into self-directed research or the postdoc. Is that the same thing or is it different?
Yeah, so I suppose in the sort of, at least in the way I understand the traditional sort of path in astronomy, I would say those two things are the same. Leaving PhD, at least for my understanding, if you wanted to continue in academia, you needed to get a postdoc. I have been out of the field, like out of the academic field for a little while, so maybe that has changed, but I don't think it has. So yeah.
Perfect. Okay, so then my question that's still directed towards you and also Jason and Rakshai. You are all in like the field of like astrophysics, astronomy, cosmology, kind of things like that. Currently, I'm at University of Rochester, and I'm in the Flash Center under Dr. Petros Stefarakis. And what we do is we do the Flash code, which is an open radiation MHD for people who don't know, magnetohydrodynamics simulation. I'm new to coding. I just did my first, as an undergrad, Python course this spring. And now that I'm using Flash, I find that I like it. However, I have a passion for like everything kind of astronomy, astrophysics, cosmology. And I was wondering, is there a way that I could marry using the Flash code and also going into some kind of field that is within that whole region of like astrophysics and cosmology and astronomy and whatnot?
So I guess I can answer some of that. So I mean the topics like cosmology and astrophysics and astronomy, it's such a big area, so I think, for example, like I work in dark matter, right? Like, so my career transition was I worked in my PhD was in nuclear physics, and my first postdoc was in astrophysics, but some of the nuclear physics, or atomic molecular physics could actually translate to detector development for astrophysics. And so in my second postdoc, I kind of ended up moving on to like quantum science too, because you could use like condensed matter systems and atomic molecular optical physics into, again, detector building for astrophysics, like dark matter detection. So I think there's a lot of room for like moving into like different areas within this field, because like they're depending on like what you do, some of it is going to be more computational heavy, some of them is going to be more detector building, even the detectors are going to be different. A lot of them are like microwave detectors, like you have radio astronomy. So I think like there's many different areas that you can go towards. So to kind of narrow down, I think it's like you have way too many options. So yes, it's possible to stick with some of the things that you want to do and you have expertise right now, and then maybe pick up some new expertise that will be relevant and go towards some novel direction that you want to pursue. Is that kind of the answer that you're looking?
Yeah, because thank you. Because right now my project is with the Rayleigh-Taylor instability, and for whoever's in the room, it has to do with fluid dynamics. Who doesn't know? And it's a dense fluid over light fluid accelerating because of the presence of gravity. And I'm using the code to test my experimental value to verify, the theoretical value. And I know that these type of dynamics occur in supernovas, and I believe at accretion disk with jets, the streams pulling through. So I was thinking, could I somehow, if the Flash code, I just really, really fall more in love with it, could I marry that like with something in that field and looking at I know some kind of experiment or something. Does any of that make sense? Because this is like new for me.
So what's universally useful is like if you have some universal coding language, like Python or something that that's going to be extremely universally useful. So I think like you have a generally useful skills that is going to be very translatable in other areas too. But whether you want to be specifically, if you want like specific analysis or like specific part of computation to translate, then that becomes a little bit narrower, right? So your options. So I can't tell you, for example, in my group, like what you mentioned, other than your Python experience will translate. Like I can't say will translate.
And
so,
Fortran.
Yeah.
And Fortran. We use Fortran for Flash.
Yeah. So there you go. So that just tells you, like, it's just such a big area that it's really hard to tell.
Okay. And if Jenna or Jason have anything input, I'm happy to hear that. If not, the next person ask their question, please.
We should go on to another question just to keep on time. Do we have a question from the room? Yeah.
For those of you who work in like I guess, professor positions specifically. I was wondering if you could like give a general idea of what your day-to-day and I guess week-to-week is in those positions. Yeah.
I guess I can start. I think all of us will have a little bit different experiences, but at least for me, my day-to-day involves a little bit of a lot of management. So it's kind of like project management, person management. So like, advising students, directing where they should be going in research. Also, working on research budgets, research proposals, things like that. And then during the school year, I'm also preparing to teach classes and teaching classes and grading and things like that. So especially during the school year for me, my week to week or day to day it becomes quite of a juggling act of you have a person with multiple roles and multiple identities and trying to do all of that, and then on top of that also trying to work on self-directed or original research on top of everything is sometimes it's a lot to balance, but it's quite fun, but it's quite hectic as well.
Yeah, I can go next. So like Jason said, it is true, like when you are in this position of being a professor, you do have many hats, like Jason said. A lot of times you will be writing proposals for different, different funding opportunities. You will be helping students with their research, coming up with new ideas about like what kind of science to do that's novel. In my case, I am leading this group here that itself has several postdocs and other scientists. And so I do have to do these data, like Excel sheets kind of thing, where I'm like crunching numbers and I'm making sure that by the end of like each fiscal year, we have enough money to pay everybody's salary and like buy equipment and do travel funds and stuff like that. And then of course, we have to also do the same for like PhD students or any students who's working with us. And then there is these committees, right? Like so at the host institution where we are from, we have to do these committee services like research council, graduate student admissions committee. Those kind of committee work also takes some time. So it's kind of all these different hats. So a typical day consists of really just tackling some of these activities.
Can I ask a quick follow-up to that?
Sure.
Yes.
So you mentioned that you do have like a lot of different responsibilities, but the reason I ask this is because I am very interested in like what I can do what careers I can follow that will put me in like actually doing research. So I wanted to ask, within the academia professions, like I guess, are you satisfied with how much of your own research you're doing, or are you more so guiding other people? Is that more of your focus?
Yeah, very good question. So probably, like I'm not speaking for myself, but I feel like probably most of us agree that like we could have more research time than like all this bureaucratic work or all this bookkeeping that we have to do. So in general, I'd say I would like more time for research. I am in this kind of unique position where I have this joint appointment. So I have one advantage over like a typical professor from a university who has this professorship appointment only and is not affiliated to like a national lab like myself. I just teach half time. So that kind of frees up more of my time to do more research. So that is one advantage, like of a joint position like mine. That's not too typical because this is just very much dependent on national labs having these local universities, some arrangement with these local universities like Northwestern and IIT with Argonne and Fermilab. That's kind of it's typical with national labs, but since there are finite national labs, it's not like there are many positions like this available. So if you can find something like this, that will free up some of your time for more research. However, in a typical position, you will, in some sense, be able to do more research when you are a professor, because you have actual students doing the work, right? So you kind of like, you are like the brain after, okay, like how does this, what makes sense to do? What is fun research, right? And so, but students will do the dirty work, right? So in some sense, you can be very productive and you can have a really fulfilling research life because you have students that you supervise, and they will do the most of the work, but it is challenging.
I'll just add that it's arguably actually more fun to direct people to do research, because then you can think about the big picture, exciting parts of the research without having to worry about the hard parts like debugging and why is my code crashing kind of things. That's for my students to figure out, and then I get to just enjoy when they are successful and think about what kind of implications the results have.
Cool, thank you. Why don't we take another question from the Zoom? Neil?
Yeah, sure. So I'm just an undergraduate right now, actually just a postbac, but I want to get a PhD in astronomy. So I'm just thinking like after that. So what are like the key areas I have to perform well in graduate school to like, increase my competitiveness or candidacy for either becoming a postbac or even a professor after that in astronomy, that is.
Who wants to go first? So I'm kind of like not doing astronomy. So as I mentioned, like I come from kind of a interesting, maybe not typical background in that my the work I do is kind of cross-disciplinary, and I come from background in nuclear physics and kind of branched out a little bit. But I think I can speak in general terms that postdoc positions, in order to get into like a competitive postdoc program, it's really going to depend on like individual postdoc program and what they are looking for, like this type of skill set, right? So in some sense, you can tailor, for example, you can build your expertise on generally relevant topics, like we discussed. For example, like coding in Python is actually one of the really, really useful thing that you can learn, and that's going to be universally useful. Some sort of design program, like if you're working on like hardware specific, let's say project, design software, like, where you can design like some piece of hardware, and you are able to like, like machine that in machine shop or something like that, that's going to be generally extremely useful. And if you can, set up some sort of like data acquisition system, hook up to like bunch of different electronics, do the readout using like, Python and other necessary software, that's going to be a very good thing. Like if postdoctoral position is open for like hands-on type of work, right? And so it really depends on like what the postdoc position is looking for, but in general, you can prepare yourself with like some universally applicable tools and tools like that.
Yeah, this might be a good question for Jason as well.
Yeah, I'll just add that there's a lot of soft skills that you don't really get taught, but I think that are really important transitioning from an undergrad to a graduate student into an independent researcher, because unlike in undergrad where you're working on these problem sets with these solutions and answers, in graduate school you're going to be working on these problems that we don't know the answer to, that may be difficult to find out the answer to, and be able to kind of make sure that you're able to constantly make progress on these projects yourself, maybe have some sort of project management skills on yourself, and keeping track, like trying to find goals and things that you can accomplish even if you don't know what the end result's going to be. I think having that sort of resourcefulness and kind of like management skills, I think, are really useful. Another thing is a lot of in academia, just as like an industry, getting your name out there and getting your work out there and publicized is very important. So being able to publicize your results, network with other people in the community, these are all very important skills, not technical skills, but also I would say equally important skills for you to work on as you progress through your career.
Yeah, and I want to add to what Jason said. So one of the things we also look for is like, have you had experience supervising, let's say, undergraduates or like other students? Because as a postdoc, you kind of are, in some sense, the professor or like whoever the PI is going to be doing a lot of like this management kind of work. So in some ways, like as a postdoc, you are going to be leading like the project in some ways, like research, because you're going to be heavily doing actual research, unlike us useless professors, right? So I think you kind of want to have that leadership demonstrated also. So supervising undergraduates, other junior graduate students, that's actually really good in your resume. As Jason said, management type of skills is great if you have already done some of that. So just independent thinking and like independently leading any project, that's kind of what we look for, as opposed to somebody who we have to just be like, do this, like postdoc is like being independent researcher. So we just kind of look for somebody who is like self-sufficient and can start a project and then continue that project in general.
Okay, thank you. Do we have a question? Yeah.
So this is for really anyone who wants to answer it. I was wondering, like, what things did you look for or value when looking for the type of job that you currently have, and how did that influence your decision to go in the direction that you went?
Maybe someone we haven't heard too much from yet. Jenna or Erica, maybe? Have any thoughts?
I can jump in a little bit. So one thing that I found when I was deciding kind of what career I wanted to go into, one thing I really realized is a lot of what I enjoyed about science, there's physics or astronomy, being in grad school, was just learning new things and just for the fun of learning how stuff works and how galaxies work, that kind of thing. And so that was one thing that really drew me to science writing, was I would get to constantly learn new things. So rather than, in grad school too, in research, you do learn new things all the time. Often, you're focused on a specific subfield or something. But one thing that really drew me to science communication and science writing is I get to learn about a lot of different topics from day to day, whether I'm writing about galaxies or I'll be learning about quantum computing, all these different topics, learning new things. And then the other aspect that really attracted me to it was then getting to kind of communicate and like tell other people about it and teach other people about it. So like teaching was another career I was kind of considering too, because of the aspect of getting to like share what I've learned with other people. But ultimately I decided science writing for me was the way I wanted to do it. Hope that answers the question.
Yeah, I'll jump in there too. So I suppose the thing I like most about the job I have now, and sort of what drew me to it, is that I think I said this before, but I get to use a lot of the skills I've already learned in grad school, and like stay in astronomy, but I'm not doing self-directed research. And so I'm focused more on the technical aspects of, astronomy programs, observing programs and doing data analysis and things like that. So I guess it's like the problem solving aspect of things that I really enjoy about this job and drew me to it. Also, I would say the sort of work-life balance at my current position is potentially better than most more serious academic appointments, I would say. The institute is fairly flexible in terms of like where you do your work and how you do your work, as long as you're completing it and putting in the hours you're supposed to do. And Yeah, and also I guess also we have good benefits and generally good pay compared to maybe like a postdoc or something, and less so compared to data science or other technical jobs or tech jobs in tech industry. Yeah.
Thank you.
I can chime in from a tech industry perspective if that's useful. I'm not sure if anyone in the room is going that direction, but I do feel like I have a couple kind of specific things that could be useful. Like right now, actually, my choice is very much just impacted by the scale of impact. Like I'm at a point in my career where I'm good at what I do, and I look for the place where I'd have the most leverage on climate change, basically. But earlier, when I was like, fresh out of grad school, for my first data science job, I was very much focused on just choosing the best company, just a company with a great reputation where I knew I would work with very good people and I would, as quickly as possible, learn everything they know. And one kind of specific piece of advice I would recommend if you go into this field is have your first job be what we call a scale up. So like a medium-sized company, basically. If you go to like a Google or an Apple or whatever, one of those big companies, you're just learning all their internal software. Your skills are going to transfer much less well because they have all this like bespoke internal stuff you'll never see again once you leave that job. And you'll also work on something very granular. And at the other end, at a startup, startups can be kind of fun. They can be a lot of work too, but also, especially if you're a machine learning person, there's so much like groundwork you have to lay as far as having a good platform on which to do your work and to productionize your work, that you can just spend a lot of time on like the core engineering components and never getting to do anything super interesting, or maybe your data set isn't that big yet. So if you are interested in data science, like look for a good medium-sized company to start with. And then the second choice I made was based on, okay, I had a bunch of skills and now I wanted to specialize into a specific industry. And I chose a company where I would have very good exposure to the real problems in that industry. So I went to a startup that had a bunch of customers across all of clean energy, like solar, wind, batteries, community choice aggregators, you name it. And by working with all these customers, I kind of figured out what the industry really needed. And so now I kind of felt like, okay, I've got like a hammer and now I know what the nail is. Now I can go do it.
Awesome, thank you.
Okay, why don't we go to a question on Zoom? I think Heather is up next.
Hi, can you hear me okay?
Yep.
Okay, first of all, thank you for hosting this today. This is a great opportunity. Second, I had a question for Erin Boyle. I'm also a chemistry major in my undergrad. I have a minor in physics and I'm currently attending an REU for astrophysics in Ohio, represent. And I know that you have some background in PChem, so I was wondering like what some possible career paths that could hold for me.
Cool, love PChem. Boy, career paths in PChem. I didn't look around at everything, so this is not going to be a thorough answer. I mean, so I did nonlinear spectroscopy as my primary focus in my PhD, and I did some pretty esoteric method development type stuff from that particular thesis. Like when I first moved to San Francisco, I did see some startup jobs that were doing like esoteric laser-based research. And, I did actually do some interviews. They didn't seem like really compelling companies, so I didn't actually go that direction. In general, I would say like, if you do something that's, method development at the forefront of your field, you're probably not going to get a job in industry doing anything very related to it. You're probably going to have a choice of, going into academia, or like, I feel like a lot of people who have experience like that do things like go into national defense and stuff. For like broader PChem research, yeah, I don't know. I'm kind of drawing a blank of any of my cohort that went somewhere besides academia or like really very different work.
That's totally okay, because like that is not the main focus now, so I understand. Thank you so much, I appreciate it.
Yeah, no problem.
All right. Yeah.
Raksha, you mentioned you did a research program in the gap year before your grad school.
Yes.
Can you describe that program a little bit? And specifically, I'm wondering if positions like those at science institutions or national labs are really only like temporary positions for development, or if there's opportunities for advancement.
Yeah, so that's a really good question. So I kind of got this position, which was really not a mainstream position that places like Fermilab have. For example, Fermilab does a lot of like summer internships and short-term internships for high school students, undergrads, etc. But this was like a 9 months program, and this was actually not. So I did my research at Fermilab, but my employer was not technically Fermilab. So this was one of the Fermilab scientists had a appointment with local university here. And so it was like I was getting paid through that university, but then you can actually be a user at Fermilab. And so I was kind of in that capacity. I was able to do research while getting paid through a local university. So I'd say like this kind of arrangement is not typical after undergrad degree. So I don't know if that's that's not going to be a reliable thing that you can apply to. But however, I have learned that apparently Slack, for example, in quantum sensing, it's starting something like this program, like where after graduation, you can work for a slightly longer period of time, like in quantum sensing in Slack. So I don't think this is a mainstream program that a whole lot of places do, but you might be able to find certain specific places that have kind of started to do something like this. So yeah, so I think that's kind of what I wanted to say. Did that answer your question?
Yeah, for sure. Thank you. That is what I was wondering, and I kind of figured that would be the answer. And for Jen, I guess kind of just related, at a science institution, you mentioned that things are like roles like yours, obviously yours is more advanced, but transitions to positions like those are more feasible from undergrad. Do you, kind of the same question, do you see that as an opportunity right out of undergrad, or is it kind of exclusively for graduates, PhDs?
Right. Sorry, you had a second component to your question. Now I remember. Yes. So typically the transition, I have like students who have done this kind of work I know of, who have transitioned into good graduate program, because they did excellent job in this kind of internship. In fact, we had a student here come through Tufts University, she did her research here at Fermilab, and now she's going to Stanford for graduate school. And so this was not necessarily because there is some sort of streamlined mechanism from going into grad program from the internship, but it's more like the people she worked with were so impressed by her work during the internship that they wanted to they put good words for a graduate program, and she got into graduate program. So the answer is there is no direct path like that guarantees that you can go into grad program. However, your work might actually decide, the quality of your work might actually decide and have a really positive impact on these people who have the capability to decide who gets admitted into these graduate programs. So that's kind of like my answer.
And then were you also asking Jenna about, Jenna, are there opportunities for people fresh out of undergrad at Space Telescope?
Yeah, sorry, I might have missed that. Yeah, so there are. My position is actually open to all levels of folks with degrees, so bachelor's, master's, PhD, and beyond. You just, if you apply and you are accepted or get an offer, then you come in at maybe a different level of, job title. But yeah, we have a number of folks on the Hubble and James Webb instrument teams, and also in other parts of the Institute that I know less about, but on the instrument teams that do a lot of kind of the same work that I do, just on different teams and different specific projects. So yes, and we are hiring about, I would say, maybe once or twice a year. So I guess if you're interested in a job relating to either instrument calibration work or user support or supporting science projects at the Institute, keep an eye out on job ads. The AAS has a great job register if you keep an eye on that.
Thank you.
Okay, and next up on Zoom is Winter.
Hello, good afternoon. So this is a question for well, anyone and everyone. So a lot of people that I know, as well as myself, are going to be graduating at the end of this coming school year. And as we, and most likely all the other seniors in the room, know that grad school applications are coming up at the end of this coming semester. So I guess my question is, or I guess the question of, oh my gosh, what the heck am I going to do with my life is becoming, pretty salient right now. So I guess if you could go back to when you guys were seniors, what would be one thing that you would tell yourself, knowing what you know now?
I can say at least one thing that came to mind for me for applying to grad schools specifically. Applying to grad schools can be such a lottery to some degree, just because there are so many qualified candidates. And even if you're totally qualified to get into a grad program, they might not be able to take you just because they don't have funding for your student. Or sometimes, depending on the program, acceptances might be kind of dependent on what faculty members are looking for students at the moment. And so it really comes to factors that are out of your control sometimes. So of course, do your best in your applications, but don't feel too badly if you don't get into any particular program, because to some extent it is a lottery.
I can jump in and express an opinion here. I'm sure it won't be the same as everyone else's opinion, but hopefully useful to some people. For me personally, I would go back and not go straight to a PhD right out of undergrad. I think I was like really swept up in the idea of being a professor, and I just hadn't been exposed to much else. Like, I had a professor parent. I really loved all my undergrad professors, and so I, wanted to go their way. And I also lived somewhere where I didn't see a lot of examples of other high skill jobs, and so I don't think I had a lot of inspiration for other things I might do. And that won't be true for everyone on the line. I'm sure plenty of you actually have a lot of experience that I did not have at that age. And so maybe you have more perspective than I did. But for me, I think I just kind of went headlong into it, excited at the idea of being a faculty member. And I didn't take the time to try to experience other things and figure out what else might be out there. And, in the end, there's definitely a much more useful path to where I've ended up. I'm perfectly happy with where I've ended up, but I would go back in time. I would definitely not go straight into a PhD. It's 5 to 6 years. It's a huge commitment in your 20s. If it turns out it's not the right choice for you, you could do things like try to find an interesting job with the skills you currently have. You could do a master's. In my mind, I think a master's is an awesome compromise where you can learn a ton in 2 or 3 years, depending what kind of program you're doing. And if you think there might be jobs for you out in the world besides academia, I think a master's is a great stepping stone in many cases. And it's short and sweet. You can try living somewhere new. You can enjoy your 20s and move around some. So I would explore other paths for sure.
I'll just add one thing, is that the what am I doing with my life part never ends. So it's just, this is just one of them. And you can, you can always change careers at any time, kind of thing. So don't feel like you have to do one thing. Don't feel like you're committing yourself to one thing. And even if one door closes, there might be another one that eventually opens for you. So it's hard, and it's hard to predict the future. So so don't enjoy yourself in the present, I would say.
Yeah, I wanted to add a few things too. And so it's going to be different for everybody. So some people will know that they really want to go to grad school, and some people will be like, I'm not sure, maybe I can take a break, right? So in my case, for example, I really wanted to go to grad school, but the thing is, I didn't do that good in like physics GRE, and like all these programs required me to take physics GRE and like do really good. And so there is a balance. So if like if you're one of those people like who really wants to go to grad school immediately, I think it's okay. It's a fine idea. The thing is, you might not get into some programs of your liking, or any program at all, like in the first try. That's all right, because I think I don't want you guys to give up on your dream of like going to a program feeling bad if you don't get it in like the first shot. So apply for next year, like make the best out of where you're at. For example, if you don't get into a grad program the first year, do some internship. Maybe it's not going to be like full paid, perfect internship that you like, but like do some sort of like academic internship for like some whatever chunk of time you can do that, and then build your resume and make yourself more competitive for the next time. And I think one of the things like I would have done differently is like, I just like, I just didn't have a whole lot of confidence in myself. And like, now looking from like different perspective as a professor, I'm like, graduate students are valuable, and like treat yourself as like, at that point I was like, you know, this professor is like God. And like, I just want to like, like I just took myself to like I just belittled myself. I just like didn't realize what potential I had. And so I think I want people to just recognize that and not put themselves down on like what they can achieve. And if you fail once, I don't like that's not going to be the end of it. And like Jason said, it's just one hurdle that you have to move past and be persistent. If you really want to go to grad school and be a researcher, be a scientist, you should persist and you should apply next time. And yeah, like hopefully you'll get into another program. So the other thing is, I wanted to say, so, master's program, like trying out master's program is good. One thing I want to mention is that most of the PhD programs actually pay for your stipend, like like a TA position and stuff. And most of the master's program actually you have to pay for it. So you might want to consider that. And it's typically, at least in science, like advisable. And this is what I advise to students, that you probably it will be best if you apply for a PhD program, even though you might not actually end up finishing it. Let's say you realize like 2 years down the road, like you just, are not built for this or something. That's okay. That happens. You can get your master's and then get out of the PhD program. So I'd say like applying for a PhD program is probably going to be less expensive for you though. So that's what I wanted to add to that.
Thank you. Questions from the room? Yeah, Amelia.
Erin, you mentioned about like, oh, you should work at a medium-sized company. Don't go straight for the Apple or the Microsoft, but being skeptical of startups. And I'm fairly certain that I want to go to grad school, but I kind of see grad school as that, quote, big company. I'm afraid that when I get out, the barriers to entry to anything besides the niche topic of my PhD will be too high to conquer. And it's like you're set there. And I that's probably a misconception, but that's kind of what I'm wondering if you could please elaborate on, is like, what did you do, or any of you, to make sure that those barriers to entries were conquerable?
Well, I think it's good that you're thinking about it. Like, obviously having a PhD is not a bad thing to have on your resume, right? Like it definitely opens some doors just on its own. And the fact that you went really deep on some area of expertise and showed your value, like people pay attention to that. That does have worth in and of itself. And something that you learn in a PhD or in any kind of research setting is just like the ability to self-direct more and like figure out what the right question is and solve the problem and kind of like do the work yourself. All of that kind of problem solving skill will transfer and help you. But yeah, like I definitely think like if you're gonna do a PhD, but you think that there's a possibility in your future of, you know, not just going into academia and going even deeper on the same research topic, I definitely think you can be a little more intentional about what kind of lab you join. So, you know, like really try to talk to advisors about kind of like what their philosophies are for how they advise their research students. And like you could even ask them, you know, you interview them a little bit when you're deciding what lab to join. Like ask them like, hey, like where have your students ended up after they've come out of your lab? What kinds of skills do they come out of your lab with that might generalize? And you know, you could like, for example, if it's you know, something where you're doing a lot of computational work, you can figure out what language it's going to be in and figure out how useful to a broad range of jobs that particular language is, for example. You can figure out if they use kind of like modern, you know, do they like use GitHub or like any cloud services? Like, are you going to pick up any kind of skills that can transfer? Obviously, I'm thinking of things that are relevant to my line of work, but you know, if you have some other interest, I think you could still ask questions that are along these lines.
Thank you.
I just wanted to also add, you can also, in your PhD, take like a summer off and do a summer internship at a company in industry. And it's pretty easy to do as a PhD student, and you can get paid more and you get that work experience that will help you land a permanent.
I didn't know that, thank you.
Okay, we have a question from BP on Zoom.
Hi. Yeah, so my question is kind of for the whole panel. I wanted to ask about when you were considering grad schools to apply to, and especially when you maybe if you had a few that you had offers from, what was important to you, and what was like your top considerations for choosing which grad schools to apply to, or what do you wish you had considered when you were choosing schools?
I guess I can start. Hello. I think you know, some of the things I thought about were, you know, which research projects excite me, not just about the name but of the school, but like which projects that I felt were promising. And another thing I really took into account were there multiple projects that I were interested in for that, working with possibly different faculty at that school. It just, a lot of times in grad school, for one reason or another, like one PhD project doesn't work out and you might have to switch. And this happens even with the best intentions and with everything done properly. It's just sometimes that happens, and being able to have other options, not just one, not going to one school just to work with one professor to work on one project. I think that helps a lot in kind of making sure you're hedging your bets on, you know, having a good project in grad school.
I can jump in here too. Yeah, so some things I looked for in choosing a program. Also looked for, you know, multiple faculty that I could see myself working with. But then otherwise, like I kind of took a, you know, less of a school look perspective on it. And also, you know, you're going to be there for maybe 5, 6, 7 years. So I really based a lot of my choices on the location. I wanted to have a city that I felt comfortable living in and maybe would enjoy living in. Another thing was generally if the students were happy, if they, you know, were they had some work-life balance, they weren't, you know, stuck in their offices all day or you know, completely not on site either. You know, just that they appeared to be enjoying their time. That was a big thing for me.
Yeah, for me,
I would agree with Jenna. Sorry, go ahead.
You go ahead, sorry, and I will follow yours.
I'll be very brief. I just wanted to plus one what Jenna said. Like a PhD is a long it's a long commitment. I mean, you can always leave, but you're going to be there for a while. It's a lot of your 20s. Try to have fun. Like, go somewhere where you're going to be happy, where like you like the faculty, you like the students, where the faculty have time for their students. You know, like I visited a lab I thought I wanted to work at Berkeley, and it had like 40 students, and the professor didn't even show up for visit weekend. Like, not not a compelling place to join. Like, go somewhere where you feel like you're gonna have some community, you're gonna be supported, and I think that'll help with every like learning and everything else you want to achieve too.
Yeah, I was going to add that, so, you know, a lot of times, probably students do not have like a clear, you know, path forward. Like, for example, like even though I did internship, like, you know, a couple of internships in my undergrad, I learned what I didn't want to do in grad school, like what kind of field I didn't want to pursue. So it was hard choosing a grad school because I was like, okay, which program do I want to? I had no idea what I was interested in. I knew what I was not interested in. So I chose a program that in general had a good, you know, like a physics research program going on. And so that's kind of one starting point. And like everybody said, I think the most important thing in my opinion was, how do you get along with your advisor? So your advisor is going to be writing your recommendation letters until like whenever. Like I had my PhD advisor write my recommendation for like this faculty position that I currently hold. So you want to work with somebody who is going to uplift you and like help you excel in your career. And so I think that's probably like going to be like the most important thing in my opinion, that you want to choose, whether you get along with your advisor. How are they, you know, like are they generally encouraging? Are they just going to be like not somebody who you can go to with like problems, you know, and discuss them in a healthy manner? Because, you know, you'll have to deal with like a lot of applications and other things. And if they are always absent, or like, you know, they can't do anything on time, that's not actually good. So I think like that was my priority. And like somebody else said, it's very normal to switch faculty advisor if you do not get along, or like you know, whether because of like interpersonal communication differences, or like your thesis project being not, you know, not up to your standard. Whatever the reason be, it's completely fine to switch. Like I have, my sister is a physicist, my partner is a physicist, both of them switched their advisors like 2 years, 3 years down the road. And it might seem like end of the world at that time, because you're like, oh my God, you know, I spent like 2/3 of my PhD already, and now I have to switch. That's completely fine. So I'd say take a, you know, like a little bit of relaxed attitude towards this, and you'll be fine.
Yeah, I would just echo what everybody else has been saying. All great stuff about, you know, having multiple faculty members you want to work with. Also, do the students there have work-life balance? And I think the important, like how to actually find out those things is to talk to current and past grad students of that program that you're interested in when you can. So that can be really helpful for learning what is the experience of being in that program actually like? What are people's daily lives actually like? So whether that's, you know, after you've applied and gotten accepted and you're visiting on campus for the admitted students weekend, or if you have opportunities to talk to grad students before you're applying to the program, even somehow to ask them about their faculty advisors, or ask them about what is the work-life balance like in the department, something like that. I think that's how you find out these things, hopefully.
Thank you so much, everybody.
So this question is for Rakshia and Jason, and it mostly has to do with becoming a professor, and because from what I've heard, it's sometimes could be a very sort of difficult path to follow, as like sometimes you always have to be changing locations, and then also like transitioning from like being like a student to being like a sort of a mentor or advisor. How essentially, how did grad school sort of prepare you for this? And like, was this what was your intention to become a professor as you're completing your PhD, or was there some sort of like external factor that convinced you to follow this path?
Yeah, so to answer your question, so I never, I mean, I knew I wanted to be a scientist. I wanted to do research, but I didn't necessarily think I would be a professor. In fact, I was kind of terrified to be a professor. I was like, I'm going to teach all these extremely, you know, like like difficult subjects to like students, and like, a part of me was like scared to be one. But the thing is, you spend so much time in your training that like somehow you just acquire training in order to be a professor. Even after like, graduate school, you have to do several postdocs. These days, to be a professor, you have to have not just one, a lot of times multiple postdocs, right? So by the time you do all of these, you are kind of like already ready to like make this transition. So it kind of becomes this gradual process. So to answer your question, when I was like doing PhD, I had no confidence or hope that I would be a professor one day. I just wanted to be a scientist doing research. And then I went to a postdoc. It was, in academia, doing the first postdoc is pretty nerve-wracking for everybody, because you are this independent researchers. Everybody is going to count on doing quality research, so count on you for doing quality research. So that happened, and then I did my second postdoc. I became slightly better, slightly more confident, and then it so happens that after I was done with like my second postdoc, I was so ready. I was already doing management work. I was like supervising students, and in some senses, like when I started my this faculty position, it was easier for me to do this job because in some case, I think, in some sense, as a postdoc, you do more difficult job, because like doing very exacting work, like hands-on work, is sometimes more difficult than like doing bigger picture work, and different people work differently. And for me, that was true. Like I'm better at like, I take less stress at doing bigger picture work, and the transition to faculty was actually easier for me, believe it or not, than a postdoc. And a lot of times anticipating a more permanent job, being a postdoc for a very long time, that itself is a very, a positive experience. So maybe that was also a contributing factor. But yeah, did I answer your question?
Yeah, you did. Thank you.
Okay.
For me, I feel like I also wasn't always dead set on becoming a professor. I just I know one of the aspects you mentioned about mentoring students, that's like mentorship and like kind of managing others, is something I enjoy, that kind of leadership position. So that wasn't something that like dissuaded me from becoming a professor. For your other point about like moving and enduring these various hoops you had to jump through to get here, I think that's always been something that I always considered. Like, do I want to apply to this postdoc, or do I want to and have to move, or do I want to stay at my current location and find some job in industry? And I've always weighed to, even starting in undergrad, about which of those I want to take. And for me, my interest in astronomy and what my research is doing and how cool it is, that's always weighed the cons. But if at any point the cons do outweigh the pros, that will make me reconsider whether I want to stay as faculty.
Thank you.
All right, Austin?
Hello, my name is Austin, and I am not interested in academia or the PhD route. I'm going to be graduating a year early with my bachelor's degree, and I'm looking to do a master's program directly afterwards for 1 or 2 years. So I'm curious to hear from your experiences what you've seen in the workforce regarding how people view people with a master's degree versus a PhD degree, and what opportunities there are available to kids just with a master's degree rather than the PhD route. Thank you.
Is your question for a specific person or anyone?
For anyone that has a relevant experience, or yeah, just has noticed any pros and cons regarding the master's versus PhD in workforces or industry.
I can jump in, like, as someone who's worked in tech for a while, and I've also done a lot of hiring myself. PhD doesn't matter almost at all, like unless you have a PhD in something that's like a very bespoke thing, like you have specifically studied reinforcement learning for, you know, battery trading in KISO, like unless it's like that, it doesn't really matter. And a master's is great. Like, and yeah, I think people come in with masters in like in data science or in statistics, or there's a lot of different like engineering disciplines that'll have a lot of good hands-on work, obviously like computer science. So yeah, at least if you're interested in the tech sector, I definitely wouldn't worry about not having a PhD for jobs there.
I could speak just a little bit about this too. I mean, so my experience is going to be pretty specific to science communication, writing, journalism. It does not matter if you have a PhD. There are certain opportunities that might be more open to you if you do have one, but a lot of the time it doesn't matter. And you can think of one way to think about a PhD is it's like one way to get a bunch of research experience and skills, but another way you could get research experience and skills or work experience and skills is by doing some job for some number of years, or, you know, trying out some internships. You know, there's multiple ways you can get transferable skills and relevant work experience, and PhD is one of them, and non-academic paths are another way to do it. So.
Okay, any more questions in the room? Okay, let's do another online question then. Allison?
Hi, I was curious, this is kind of a question for anyone who wants to answer. What kind of career opportunities are there in sort of the realm of theoretical physics? Because I've been noticing whenever I'm sort of looking at different grad schools and stuff, that there seem to be more positions available in kind of the experimental physics area. So I'm just sort of wondering what kind of opportunities there are in theoretical physics, either in like the academic side of things, or even if there's any kind of path in like industry for theoretical physics, and maybe with a focus on the area of like on like gravitation at all. I don't know, I'm just curious if anyone has any insight on that.
So I can answer that a little bit, even though I don't have experience with theoretical physics myself. I have secondhand experience from my partner who's a theoretical physicist. So in general, I think what is true is, let's say, you know, for jobs after graduate school, it seems to me that the openings for theoretical physics positions are, you know, like more limited than like experimental physics. There is this physics. There's just a lot of you know, funding opportunities in different areas of experimental physics compared to like theoretical physics.
Right.
So that is in general true. So your job opportunities are going to be very dependent on your area. For example, you know, right now, like if you end up doing like something like quantum computing, or, you know, something that's hip, you know, like your prospect of getting job opportunity is going to be slightly different than, you know, like let's say you do traditional like particle physics or like nuclear physics, you know, like research. So to answer your question, in academia, the jobs for theoretical physics are limited. To give you an example, you know, in a national lab, you know, like nearby here in Chicagoland area, I know there was one position where there were 200 applicants for like a staff scientist position for like this job in theoretical physics. So that's actually pretty high. So outside of academia, I think you would have, and I'm not qualified to answer that much, but I think you would have to translate your background in, computational physics, or, what kind of tools you used, like Python, Fortran, whatever you use. How does that translate to like the company that you're applying for? Like, you have to kind of like speak their language and like kind of be able to translate your super like theoretical work into like more like application oriented, application oriented position that you're applying to. So I think there are opportunities, but maybe somebody else can who has this information about non-academic jobs can answer this better.
Okay, great. Good to know.
I think that we maybe have time for one more short question. Is there any last questions from our room? Okay, then let's go to Carly for our final question of the session.
Hi, thank you. I have a question about science communication. So I know that there's a wide range in both the amount and type of science communication that one can do. Obviously, someone like Erica is in a very focused science communication position, but I understand that many professors also do outreach. So for those in academia or industry positions, what sort of outreach do you do? And then for Erica, do you have any advice on improving science communication for people who aren't in strictly communication focused positions?
I can jump in really quick on that last bit of the question. So if you do want to do some outreach or communication and you're not in a, but you're in academia or some other job and not a completely communication focused job, I think, yeah, just looking for what opportunities you might be interested in and doing them. And a lot of it's going to have to be informal, probably. Like there are a lot of scientists who do kind of outreach and stuff on social media, or who do outreach programs at their research institutions or universities, or start things like science on tap type things where you go and give talks at bars about science. So there's a lot of different things you can do just to kind of get out there and share science with people. You can also look into opportunities. There are a lot of resources out there for training scientists into being better communicators and like how to, distill science down to a more accessible presentation or things like that. So looking for opportunities like that could be another thing to do.
In universities, I think actually something like teaching Astro 101 is a great way to practice science communication.
Very true. All right, so we're at 3:30, so just about out of time. Let's give all of our panelists a round of applause. Thank you guys for being with us today.